Okay, so the purpose of this video is to try to better understand what the sine function is and how to use the sine and sine inverse functions in calculations. So first and foremost, it's important to understand that sine, cos and tan, the three trigonometric functions, will only work in their basic form for right angle triangles. Now, later on in your career, you may come across the sine function, the sine rule and the cosine rule, and those ones will work for any kind of triangle, but in its most basic form, when it's given here, it will only work for a right angle triangle. So first of all, what is the sine function? So the sine of an angle is defined in terms of two of the sides in a triangle. The first one is basically the ratio of the side opposite to an angle. So if I take an angle B here, then the side opposite to B divided by the hypotenuse gives me the sine. Simple as that. It's just a ratio of the two sides. So for example, if I look at this triangle that I've got here on the right hand side, I've got the side opposite is 6 centimeters and the hypotenuse is 10 centimeters. So then the sine of this angle down here, which we'll call A, would be simply enough just 6 centimeters divided by 10 centimeters. Now, first and foremost, you should notice that the units cancel and leave me with 0.6, okay? Which means that the sine of the angle A turns out to be 0.6 or 3 over 5, or you could just leave it as 6 over 10, or whatever you like, really. It's a ratio from one side is to the other side, so really that's what we're getting. We're getting a ratio between the side opposite to the hypotenuse of that triangle. And what we're saying is that that is 6 is to 10. Okay, so fabulous. Now calculate the sine. You've used the sine function on your calculator, and you've you've not used the sine function on your calculator yet, actually. You've just done a little bit of division, and you've got this thing to work out to be 0.6. What does that actually mean, or how is it of use to us? Well, it becomes more useful to us when we do the opposite operation. So the sine function gives us a ratio, while the sine inverse function gives us back the angle. Okay, so if I want to calculate the angle A, then what I do is I take the sine inverse of both sides of the equation. So let me just rewrite it a little more straightforward now. I know the sine of the angle A is 0.6, and what I do is, mathematically what I do is I take the sine inverse of both sides. So I'm taking the sine inverse of the sine of the angle A, and if I take the sine inverse of the left hand side, then I have to take the sine inverse of the right hand side as well. Now mathematically, sine inverse and sine are opposite operations, just like multiplication and division, addition and subtraction, so on and so forth. So they'll essentially cancel, and that leaves me with the angle A equal to the sine inverse of 0.6. Now if you plug that into your calculator, you'll get a number like 36.887, we'll say, degrees, or approximately 37 degrees. Okay, so that means the angle A is around 37 degrees. So this now becomes really useful. So now, just from knowing that little piece of information, the lengths of the sides, or the lengths of two of the sides even, I can determine that the angle in that corner is actually 37 degrees. And because I already know that this one here is a 90-degree angle, that means that this one has to be 53, because it's 90 minus 37. Okay, so this becomes really useful. Okay, so just one more thing on the sine function before I set you up to do some practice work, is that so long as we keep the same ratio. So if I was to make the triangle as big as possible, let me zoom out a little bit so that you can see what I've done here. I've basically just doubled the size of everything really on the triangle, which means that this side is now 16. This side would now be 12 centimeters, and this side would now be 20 centimeters. But because this keeps the same ratio, I've got 12:20. Well, it's the same thing as 6:10, which is the same as 3:5. And we know that this is also a 90-degree angle because it follows on from this. It has to be a 90-degree angle because it's perpendicular it's parallel to this one here. So that means that I have to have the same angle down here, and it also means that the sine of the angle has to be the exact same. It just means that I have to have 37 degrees in that corner, no matter what. So even if the triangle becomes absolutely huge, like way bigger, if it was 1600 is to 2000, if it was 1200 as the side opposite is to 2000, it would still have an angle of 37 degrees in the left hand corner. And that's important, that's really, really useful because now you're not just getting the answer to any one triangle, you're getting the answer to any triangle that has an angle of A in that bottom corner. And what we're saying is that the ratio of the side opposite of any triangle that has a 37-degree corner and a 90-degree corner here, the ratio between the side opposite is to the hypotenuse will always be 3:5 or 6:10, regardless of how big or how small the triangle is. And that's really, really useful information. Okay, hopefully that makes a bit of sense to you. Please try and practice questions if